Hey, we're going to work through Chapter 11, Homework 11, and let's do it. So our word of the day was inscribed angle, which means it's an angle happening on the circle. And so it's happening on it, and what I mean by it's happening is that the vertex is on the circle. So I'm just going to identify, it says state if each angle is inscribed, and if it is, name the angle and the intersected arc. Okay, so A is on the circle. Uh-oh, the angle is not, so this one's looking like no. Okay, we'll come back to that. But X is on the circle. This looks like an angle happening on the circle, right? And the vertex is on the circle. Okay. Oh, no. So maybe also looking at our notes, I can compare the inscribed angle to this picture. So an inscribed angle, so they said angle BAC is inscribed. The vertex of the angle is on the circle, and the sides of the angles contain the chords A, B, and AC. So they're talking these two chords are kind of creating that angle inside of there, and that's what the inscribed angle is. That's our angle. So I'll put a necklace on that so you know I'm talking about that angle. Okay. So it looks like this would be a yes, and that would be a yes, because the angle chord BA and chord CA are creating this angle that's happening, and the angle is happening at the vertex. So, and then they said, go ahead and name it. So I'm going to do that. So I'll call that angle BAC. You could have also called it angle CAB. I probably don't want to call it angle A because I like the capital 3 letters. It gives it a little bit more clarity. This one, I would call it angle VXW or WXB. And I feel pretty good about that. These are chords. VX is a chord, WX is a chord. The two chords are creating that inscribed angle, because it's an inscribed angle because the angle itself is happening on, the vertex is on the circle. Here the vertex is not. This one looks like a central angle. So angle LMK is actually called a central angle. Okay, and the reason why I know that is notice that the name of this circle is circle M. We name circles by their center. And notice the letter M is happening in the middle, and that's the angle. This angle right here is called a central angle. Okay, now here is something else, not sure. I'm not sure what to call this, and that's okay right now. If I don't know what to call this, I think that's okay at this point. Maybe all the time. If you don't know, and I don't see anything like that on my sheet, it's definitely not an inscribed, and that's really all they've asked of me is it an inscribed? Okay, and if it is, name it. Now, moving on. The measure of the arc or the angle indicated. So if you want, we can make X what we don't know. The problem is that sometimes they already use the letter X. So it really doesn't matter to me. Also, it doesn't matter. It's just there's more than one technique. What I do want you to be focusing on, though, is what I call my little snow cones, where it looks like an inscribed angle that came from two chords created an arc. So I'm just going to highlight those. So it looks like this inscribed angle, the one happening at the X, had two chords, and they created this arc out here. This one's kind of hard. My inscribed angle here is at 35, inscribed angle, and here's the arc it created. Okay. Maybe I need another color because I'm also seeing that this would be an inscribed angle. So angle FEP is inscribed and FED is also inscribed. So this would be, maybe I could think about this one as another snow cone. Okay. Angle 49. Oh, I got multiple ones going on here. Look at this. It's getting confusing. I got a snow cone here. Bam. I got one here. I am. And I got one here. Very kind of confusing. Okay, so this is going to, little by little, get harder. We're definitely noticing that it's going to get harder. We started easy, it's going to get harder. So let's start with easy. So the inscribed angle has to be half of the intercepted arc. So this was the intercepted arc, and since arc BC is 80, they said find the measure of the arc or the angle. Well, the arc was given to me, so they must want the angle. So angle BAC has to be, well, as we said in class, the tip of the cone has to be half of the snow. So what that really means, so I'm thinking this is 40 degrees, and that's our answer. But what that really means is that the inscribed angle is half of whatever the intercepted arc it creates. So the tip of the cone, which is the inscribed angle, is half of the snow. The tip of the cone, the inscribed angle, is half of, and this, the snow part, is this intercepted arc. Half of the intercepted arc. Okay. So that's what our worksheets were saying, that the inscribed angle is half of the intercepted arc. So an intercepted arc is created by two chords, and the angle that was created by the two chords has to be half of whatever the intercepted arc is. Lots of vocab words. But I think that it makes sense that this would be 40 and that's 80. So let's move to the next one. Same thing, the inscribed angle, and that's the intercepted arc. So the tip of the cone, 42, would have to equal half of the snow, WV. So if the tip is 42, this would have to be 84. Now let's double check our answer. Is the tip of cone 42, half of the snow, 84? Yep. And these are in degrees. Okay. Next one. I'm going to create this. The tip of the cone, 35, has to be half the snow. So that means I know that has to be 70. Let me just double check. Yep, the tip of the cone, 35, is half the snow, 70. Now, I'm not sure about this, but we noticed something in class that was very interesting. We also noticed that we have a definition for arc FD, or FD that way. Because FD goes through the center, FD is a diameter. So because FD is a diameter, we also know that what just got created was a semicircle. We worked on that today too. And we also know that semicircles are half of that, half of all the way around. So we technically know that this has to be 180. So we can kind of work backwards. If this arc, this whole thing right here is 180, and I know that's 70, I know this would have to be 110. So a little bit of math there, and we talked today about arc addition. So 70 plus 110 should add up to 180. Now I can work backwards. So the snow here is 110, which would mean this would have to be 55. But they didn't ask for that. This was the part they asked. This is where the question mark was. So I'm totally okay with that. I know arc PD was what they asked for, and I know it's equal to 110 degrees. Okay. You can kind of see in this question how some of these are going to there's going to be a lot of steps with these. Sometimes only one step, 2 steps, sometimes multiple steps. Okay, let's take a look at this one. Okay, so if I look at just my orange snow cone, the tip of the cone, if I knew what it was, would be half of this snow, and that's what they want me to find out. If only we knew how to figure out what angle there is. So I'm really hoping you see this triangle living inside of here and you think about the triangle sum theorem, because the triangle sum theorem states that all three of these angles have to add up to 180. So if they all have to add up to 180, we actually do know what that inscribed angle is. Okay, 61. So if the inscribed angle is half of the intercepted arc, that must mean that our question mark, what they've asked me to solve, has to be 122. So DC has to be 122. Why? Because the tip of my cone, 61, has to be half of the snow. Voila. Check out the next video for the back.